are in the outdoors, ready to learn about pulleys. You might have been in class and been like, why are there all these pulley questions? I'm so bored. Well, it is really useful for a lot of situations, for example, in crevasse rescue. How a pulley works, if you notice, there's on this pulley, there's 22 kilonewtons pointing up and 11 newtons on either side. This is the max weight that the pulley can take, and what it kind of tells you is that double the force is going to be pulling on the top as there is on either end. And this makes sense from Newton's second law, because if the system is not accelerating, all the forces must add up to zero. And so the force that's pulling up here on the carabiner will be double the force of each single force pulling down on the rope here.
Hold up. Some of you might be wondering why I'm not including gravity in this diagram. And it's because once I lay this setup on the ground, as it will be used in the crevasse rescue system, gravity will be basically perpendicular to the tension, and so we'll ignore it in our analysis today. But I like how you noticed.
So we can see that, and we can use that to our advantage in order to pull people up. So for example, we might be crossing a glacier. There might be crevasses, these huge giant cracks in the ice as it's sliding down the mountain. And if someone falls into it, you want to be able to pull them up. I am a slightly smaller person, so I cannot necessarily pull up someone who's bigger than me, and you're fighting gravity, they're not helping, there's friction, there's a lot of things against you. And so we like to use pulleys in order to help us get an advantage and make it easier to pull up. So I will show you how the system works. I have one pulley here, and then I'm going to put in another pulley down there.
So, to re-explain the problem mountaineers have, they want to pull their partner up out of a crevasse, but they don't want to have to pull the full weight of their partner up because that would require a lot of strength. So the question on our hands is, how can we decrease the force needed to pull someone up? Well, from conservation of energy, we know that work in equals work out, and work is just force times distance. So if we want to decrease the force we put in, let's say to 1/3 the weight of the climber, then we'll have to make the distance in to be 3 times the distance out in order to make both sides equate.
I'm pulling here, and let's say I'm pulling with a strength of 1 Newton. And this is 1 Newton, so as we talked about before, this strand here is also going to be 1 Newton. But that means this carabiner can hold a weight of 2 Newtons, because each strand has 1 Newton. So I'm pulling 1 Newton, this one can do 2 Newtons. And now here we have 1 Newton along this strand and 1 Newton along this strand here. And now this one is pulling a weight of 1 Newton, and then we remember this prusik here that was holding 2 Newtons. And so this is 3 if you add up the 1 from this strand and then the 2 from here. We got 3 Newtons, and I'm pulling with a strength of 1 Newton. So we got a 3-to-1 system when I pull up here.
Mechanical advantage is just the ratio of the force we get out over the force we put in. In our situation, the force out is the weight of the climber, while the force in is how much force is required to pull on the rope. So with the z-pulley system, which is a 3-to-1 mechanical advantage system, for every 3 newtons of weight of the climber, we just have to pull with 1 Newton. But then, our rope has to travel a greater distance. For every 3 meters of rope I pull through the pulley, the climber is only lifted up 1 meter.
And that's some physics in action for you.